Hi everybody, Mr. Garrett here, and we're going to go through a couple parts of Chapter 5, Section 1 and 2, where we're talking about points on the unit circle. Now, we all know that unit circle is any circle with a radius of 1, and the center is at the origin, okay? And if we know that, then we can calculate the points on that unit circle by using angles that we can measure. So here's one thing that we know is that every point on the unit circle follows the pattern that x squared plus y squared is equal to 1. Why is that? Because if I draw a unit circle over here, and I know that the radius is 1, so this point here is 1, 0. If I draw a line up to this point has units x and y, or coordinates x and y. How did I get there? Well, I went x units to the right and y units up. So this is x and this is y with a radius of 1. This is a right triangle, and because it's a right triangle, I know that x squared plus y squared equals 1 squared. Well, 1 squared is 1, and so simply x squared plus y squared is equal to 1. So what does that mean? Well, it means that we can show points are on the unit circle by showing that this squared plus this squared equals 1. And so that's all we're going to do. We're going to say x squared plus y squared equals 1 is our identity that any point on the unit circle follows that pattern. And then I'm going to plug in my x coordinate of 4/5, square it, plug in my y coordinate of negative 3/5, and square it. I'm going to see what I get. 4/5 squared is 16/25. Negative 3/5 squared is 9/25, positive 9/25. And if I add those together, I get 25/25, or 1, and that is equal to 1. And so what I've done here is I've shown that this point, 4/5 and negative 3/5, is somewhere on the unit circle. Now, where in the unit circle? Well, because the x value is positive, it means that I'm either going to be in the first quadrant or the second quadrant, because I had to go to the right. Because my y value is negative, that means I'm going down, and so I'm actually going to be in the fourth quadrant. Why is that important? Well, it's very important to understanding how these quadrants are divided. If we look in the first quadrant, all our x's and our y's are positive, and so both x and y is positive. In the second quadrant, our x's are negative and our y's are positive. And so I can tell just by the coordinates of the point what quadrant it's in. Same thing here down in the third quadrant. I know that the x value is negative, the y value is negative, and therefore when my x's and y's are negative, I know the angle's in the third quadrant. And in the fourth quadrant, my x's are positive and my y values are negative, just like I have here, so I know it's in the fourth quadrant. Now, down here, it says the point P is on the unit circle. Find P, x, y, given from the given information. So we're looking for the coordinates of x and y. The x coordinate is 4/5, so here's my x. We need to find y, and we know it's positive. Well, again, I know that x squared plus y squared equals 1. So I know that if this is 4/5, I can plug it in and solve for y. This is 16/25 equals y squared, or plus y squared, sorry, equals, I'm going to make this 25/25 because we want a common denominator. If I subtract the 16/5 from both sides, I get y squared equals 9/25. This should sound familiar because we just had a problem like this. And if I square root both sides, when we square root an equation, we got to make sure that we do plus or minus. So y is equal to plus or minus, positive or negative, 3/5, because the square root of 9 is 3 and square root of 5 is, or square root of 25 is 5. Now this says the y coordinate is positive, so that means that I know that my y value is positive 3/5 based on the problem. And so my point P has coordinates 4/5 and 3/5. And it's also located in the first quadrant. So that kind of is helpful. Now the other thing that we can talk about is the trig function identities. And this here is talking about relating the points on the unit circle to trig functions. And so sine of t is equal to y, cosine of t is equal to x, tangent is y over x, and then our reciprocal functions, cosecant of t is 1 over y, secant of t is 1 over x, and cotangent of t is x over y. The other important identities are the Pythagorean identities, which we have here. This one here is the granddaddy of them all. Sine squared plus cosine squared equals 1. From that, we can develop tangent squared plus 1 is equal to secant squared of t, and 1 plus cotangent squared of t equals cosecant of t. This one here is probably the most important because that will allow us to take any sine or cosine and relate it to the other trig value. And if we know sine and cosine, we can figure out the other 5 or 6 trig functions. So we're going to see problems that look like this. It says the cosine of t is equal to 3/5, and t is in quadrant 4. Find the values of the trig functions at t. Well, again, we know that the sine squared of t plus the cosine squared of t is equal to 1. So what I'm going to do is I'm going to plug in the 3/5. So I'm going to say the sine squared of t is equal to, or plus, 3/5 squared equals 1. 3/5 squared is going to be 9/25, so sine squared t plus 9/25 equals, I'm going to make this 25/25, because now when I subtract 9/25, I get the sine squared of t equals 16/25. Well, if I square root the left side and square root the right side, I know that I get the sine of t is equal to 4/5. Because we took the square root, we're going to put plus or minus. Now, in quadrant 4, we know down here is quadrant 4, we know that the x value is positive and the sine value and the y value is negative. And because sine is the y value, we know that the sine of t for this is going to be negative 4/5. And that's also equal to y. So we have the cosine, which is equal to x at 3/5. The sine of t as negative 4/5, which is equal to y. I can easily figure out the secant of t because the secant of t is just the reciprocal of the cosine, so that's going to be 5/3. The cosecant of t is the reciprocal of sine, and so that's going to be negative 5/4. And then we have the tangent, and the tangent of t is going to be y over x. Well, in this case, or sine over cosine, I have negative 4/5 divided by positive 3/5. And for those of you that won't use a calculator, that's good. You get negative 4/5 times the reciprocal of 5 over 3, thus canceling out those and getting negative 4/3 as our tangent. And the cotangent of t is easy because that's x over y, which is the reciprocal of y over x. And so we can just say that's negative 3/4. The other big thing that you want to do is check your signs. In the fourth quadrant, we know that cosine is positive along with secant, its reciprocal. Everything else is negative. And so here we can see cosine is positive and secant is positive, but we can see that cosecant is negative, tangent is negative, cotangent is negative, and sine is also negative. Here's another problem where we say write tangent of t in terms of cosine of t, where t is in quadrant 3. Okay, so let's kind of think about this. Tangent of t. How can I write that so that we get cosine? Well, I know that the tangent is the sine of t over the cosine of t. So that's a good start. There's one cosine. Now we got to think of this. Well, in a little side note, I know that sine squared of t plus cosine squared of t is equal to 1. Well, let's see what sine is. Well, sine squared of t is equal to 1 minus cosine squared of t. All right, can I square root this? Sure can. And if I square root that, I get the sine of t equals plus or minus the square root of 1 minus cosine squared t. Now, in quadrant 3, is the sign positive or negative? Well, let's think about this. Quadrant 3 is here. Sine is my y value, and I'm negative x and negative y, so that means it's negative. So really, the sine of t for this t value is going to be negative square root 1 minus the cosine squared of t. And so what I can do is I can substitute that in up here. So I'm just going to write it over here and say equals negative square root 1 minus cosine squared t over cosine t. And that's the tangent in terms of cosine. So this is just an early step to solving or proving trig identities using other trig identities, and we're going to use those throughout. So I hope this helped out, and good luck on that homework.